Welcome to Process Analytics. I am Dr. James Rowe from the College of Business at Rowan University. Here's the roadmap of the course. We have learned so far the define phase before. We're going to learn define, measure, analyze, improve control phase, which is known as the make process. And then we will apply that to Disco and Celonis. And lastly, term project will be overarching project for everything. In define phase, we learned the importance of taking the time to define the problem, customers, and the processes. Particularly, we learned how to draw process map. Now we arrived at the second module of the course, measure phase. After defining the problem, customers, and processes, we need to measure the process so that we can understand it deeply. A number of things can be measured, but we need to focus on the vital views because data collection is costly and time consuming. We cannot emphasize enough the importance of measuring the right data in the right way. Module 2 pertains to measure phase. In this phase, we will lend our attention to three things. First, we'll learn about process metrics, then value stream mapping, then process capabilities. Let's first talk about process metrics. Before jumping into process metrics, let us consider this quote by Peter Drucker. He said, "If you can't measure it, you can't manage it." Peter Drucker has been described as the founder of modern management. He contributed a great deal to the invention of the field of management. He puts much emphasis on measurement. What is not measured is not managed, he said. This is an important adage to keep in mind when designing and managing processes. Well-organized metrics are critical because they help to better identify areas where a process can be improved. Detailed metrics can also help measure the effectiveness of a process. Done correctly, they can aid management in identifying defects in business, such as causes of waste, variability, or customer dissatisfaction. If metrics are carefully monitored, they may help diagnose the root of the problem as well as list several key areas for improvement. The first topic of this module is process metrics. Under this topic, we will overview three main process metrics, such as time, count, and outcome-based measures. There are a plethora of process metrics. Three types of the metrics are time-based, count-based, and outcome-based measures. Time-based process measures include metrics dealing with the time or speed of product or service movement. Lead time, cycle time, waiting time, and motion are good examples. These time-based process measures gauge how long it takes for a product to be ordered and fulfilled. Or we can think about the speed it takes for a business to process a supplier's application. Among many, cycle time and talk time and clicker measures are something to consider. Count-based process measures indicate the number of the things that go into a process. Examples examples are how many steps a process consists of in order to complete the work. When a task is transferred to another person, the job needs to be re-explained and notified. This process sometimes creates confusion or simply the task might go missing. A good process reduces the number of handoffs. Similarly, the number of decision points, loopbacks, delays, forms, complaints, and backlogs are telling measures of the effectiveness of a process. Outcome-based measures are self-explanatory. Customer satisfaction, direct costs, savings, attract the attentions of the management naturally. There could be many measures. It will be resource intensive to collect all the data. It is an organization's decision to select appropriate measures that are important for the process management. Takt time is one of primary process metrics. Takt time is the amount of the time an item or service needs to be completed if a customer's on-time delivery deadline will be met. The amount of time between one part being completed and the next part being completed must be the same or less than the talk time. Or we can assume that the parts will not be produced per the customer's schedule. It can be derived from dividing total daily operating time by total daily customer requirement. Say a company has 8-hour shift and two 20-minute breaks, then the operating time is 440 minutes per day. Customer requirement is the demand of a product or a service per day. It can be calculated, for example, when dividing total demand per month by total working days per month. In this example, 880 divided by 20 yields to 44 units per day. Give or take, this company needs to produce 44 products per day in order to keep up with the demands. Therefore, talk time is 440 minutes divided by 44 units, which is 10 minutes per unit. In other words, the company should be producing a product every 10 minutes. If one enters this company's production facility and observes the process, he or she should be seeing at least one product is being manufactured at every 10 minutes. If the production time is slower than this, the company will eventually suffer from backlog and cannot effectively meet the demand of customers. So talk time is like a pulse of a company. It's a great measure to check the health and efficiency of a process. To be plain, cycle time is the time it takes for a process to actually complete. We thought about talk time from previous slide. Talk time is the heartbeat of a process that it should be. If it is healthy, it should be, say, 85 beats per minute. Now, cycle time is the actual time it takes to complete the process. It could be higher than or shorter than the talk time. The general rule of thumb is that cycle time should be less than talk time. If cycle time is longer than talk time, the process needs to be improved. Now, inside of the cycle time, we can think about value added time and non-value added time. Wait, inspection, return, and queue time are usually non-value added time. Once a business realizes that there are non-value added time inside of the cycle time, it can think of ways to reduce or eliminate them. Little's Law is an incredibly powerful tool in the arsenal of almost any business process analytics. Little's Law is an equation showing that the average number of customers in a queuing system is equal to their average arrival rate multiplied by the average amount of time they spend in the system. In other words, throughput rate can be understood as arrival rate and flow time as the time spent in the queue. After all, however good product it might be, it is painstaking to see it going through a very long wait time. Little's Law tells us the importance of reducing the wait time as much as possible. Otherwise, work in progress inventory will quickly accumulate. Little's Law also tells us the importance of processing an item. The throughput time is an indicator how speedily a product or service can be processed in the system. Little's law has gained a wide application to understand the expected amount of work in progress um, and inventory and process speed and queuing time. Now let's take a look at a few questions. What is the best definition of takt time? A. It is calculated time element that equals customer demand. B. It is the speed at which parts must be manufactured in order to satisfy demand. C. It is the heartbeat of any lean system. D. It is the application of Kaizen to continuous flow manufacturing. What do you think? The best answer is C. It is the heartbeat of any lean system. Next question. If the throughput rate for an operation is 3,600 units per hour, what is the cycle time in seconds? So we learned that throughput rate is 1 over cycle time from Little's law. So if you put that into this formula, then it will be 1 over 3,600 per hour times 3,600 seconds, which yields to 1 second. So the answer is A. The third question, if the throughput rate for an operation is 3,600 units per hour, what is the cycle time in seconds? The name Takt is German for baton, implying a rhythm, pace, or heartbeat for the system. Throughput rate is 1 over cycle time. Therefore, the answer is again A. Let's take a look at this question. Calculate the takt time for the provided system data. So takt time equals available production time divided by customer demand. So we see that 60 minutes divided by 30 units gives you 2 minutes. So the answer has to be 2 minutes. The takt time is 2 minutes. What about cycle time? Cycle time is adding up the time it takes to make one product. So if you add everything up and divide it by um, the customer, it should be 60 divided by 20 plus 60 divided by 40, 60 divided by 12, and 60 divided by 16, which gives you 13.25 minutes. So we see that cycle time is much greater than talk time, and which tells us that this process needs to be improved a great deal. Last question is, Little's law is widely used as a determination of what? The answer is B, process flow times.